Would you abandon a perfectly good ship and leave it to sail off into the unknown? That's exactly what happened when the Mary Celeste was found drifting, lifeboats missing, its cargo untouched. But was it a ghost ship, or just a mystery waiting to be solved? The story of ghost ships has haunted sailors and writers alike for centuries. From derelict vessels drifting through the fog to eerie stories of unmanned ships wreaking havoc, ghost ships have sparked curiosity and fear. But what if the truth behind these mysterious ships was more about physics than the supernatural? Let's dive into the chilling tales of ghost ships and the science that explains why some ships drift alone across the seas. Imagine you're a sailor, spotting an abandoned vessel drifting toward you without a soul in sight. It's like seeing a ghost, but there's no supernatural force behind it, only nature's incredible laws at play. Ships like the Mary Celeste have baffled people for over a century. The question is, why do these ships appear to sail themselves? How could an entire crew vanish, leaving their ship to carry on without them? It's a puzzle that goes far deeper than folklore. One of the most famous ghost ship stories is the Mary Celeste, discovered in the Atlantic in 1872, completely abandoned with no sign of a struggle. The lifeboats were gone, but the ship itself seemed fine. No damage, no sign of a disaster, just an empty ship. What happened? Some speculated piracy, others suggested foul play, or even aliens, but the truth is far less dramatic. It all boils down to two key scientific concepts: buoyancy and fluid dynamics. Buoyancy is what allows ships to float, even if they're made of steel. Archimedes' principle tells us that objects float because they displace an amount of water equal to their weight. But when a ship takes on water, something else happens. Fluid dynamics steps in. Water inside a ship's hull doesn't necessarily spell disaster. In fact, if the water inside reaches an equilibrium, meaning it fills the hull to the level of the sea, the ship can remain afloat. This was the case with the Mary Celeste. The ship had flooded, but the water didn't reach a level that could sink it. Instead, it simply stabilized. But even stranger things happen when you throw salt into the mix. Take the story of the A. Ernest Mills, a schooner that sank after a collision. 4 days later, it was spotted back at the surface, floating as if nothing had happened. The reason? Salt. As the salt in the cargo dissolved in the water, the ship became lighter and rose back to the surface. It was a perfect example of how the ocean's dynamic forces can bring a ship back from the depths. Perhaps the most eerie part of the ghost ship phenomenon is the multiple sightings of the same ship, often years and hundreds of miles apart. How can a ship, left abandoned, appear in multiple places after months or even years? The answer lies in the ocean's powerful and invisible currents. Ocean currents act like invisible rivers, moving water across vast distances. Factors like temperature, salinity, and even the Earth's rotation affect how these currents move. But it wasn't until the late 19th century that scientists began tracking these currents in earnest. In 1883, the US Hydrographic Office began collecting data on navigation hazards, including derelict ships. What they discovered was the path these ships were taking, often drifting along with powerful currents for hundreds of miles. The mystery of ghost ships isn't a supernatural one. It's a fascinating combination of human error, natural forces, and the science of fluid dynamics. Ships may not be haunted by vengeful spirits, but they're certainly affected by the powerful currents and forces that move across the oceans. And though we may never fully understand the fate of the crews who vanished, the ships they left behind tell a story of their own, one of the sea's incredible and mysterious power. If you want to learn more about these incredible stories, don't forget to subscribe and join us for the next adventure on the high seas.